Okay, so now we're going to go through and fill out the information based on the equations we were given. So letter A, we were talking about temperature variation, so I need to find my max minus my min, which means I need to do for the max C plus A, and for the min C minus A. So we have to do this twice. So Bar Harbor, I think I called that Bay Harbor, oops, and Phoenix. So the max for Bar Harbor is going to be 55.300 plus 23.914. And I'm just, to make this simple, I'm just going to round these numbers. So we're going to call this 55 and we're going to call this 24. We're going to call this 87 and we're going to call this 20. So my max is 55 plus 24, which is 79, minus my min, so 55 minus 24, so that's 31. For Phoenix, it's my max 87 plus 20, getting that from C plus A, so 87 plus 20, that's 107, minus my min, 87 minus 20, so that is 67. And then we'll figure out which one's bigger. So 79 minus 31, you get 48. And then 107 minus 67, you get 40. So Bar Harbor has the larger variation, which it says, yes, that's true. According to this, it says is more in Bar Harbor, which it is more. So this is wrong, because we're looking for the one that's not true. It says which could not be concluded. Letter B, the midline average monthly temperature in Bar Harbor is lower than the midline for Phoenix. Well, Bar Harbor, the midline, is your C value, so that's 55. And Phoenix has a midline of 87. So it's 55 versus Phoenix's, which is 87, which means Bar Harbor's is lower, which is true. Therefore, this is not our answer. C, the maximum average monthly temperature for Bar Harbor is 79 degrees. Well, we already calculated that when we were finding the variation. So Bar Harbor does have a maximum of 79, so that is true, therefore not our answer. Finally, D, the minimum average monthly temperature for Phoenix is 20 degrees. Well, we found Phoenix's minimum to be 67 degrees, so that is not true. Therefore, that is our answer. Number 10. A circle centered at the origin has a radius of 13 units. So I'm going to start by drawing that. So we just have a circle, and it has a radius of 13. The terminal side of the angle intercepts the circle in quadrant 2, which is where I drew it, at point C. So this point is called C. The y-coordinate of point C is 12. So this is the point something, comma, 12. What is the value of cosine? So if my y value is 12, that actually tells me this side of the triangle, because the y value controls how much your point has gone up or down. It's your vertical change. So it is a value of 12 for the opposite side of my triangle from our angle, which I'm going to draw in there. So that's theta, which means I'm just missing the adjacent side, which if I have two sides of a triangle, I can find the third one by doing the Pythagorean theorem. So I'm just going to call that third side x for now. So 12 squared plus x squared equals 13 squared. So to find x, I'm just going to subtract 12 squared. I'm going to do it all at one time. So I get x, and then whatever I get when I subtract, I have to square root to get the x by itself, because I do have the square root of x, or I have x squared. So 13 squared minus 12 squared. I get 25, and then I square root that, so to the 0.5 power, you get 5. So the third side of my triangle is a 5. So if I want the value of cosine. Cosine is adjacent over hypotenuse. So cosine of theta equals next to my angle, which we just found is 5, over the hypotenuse, which is the 13, but now I just have to pay attention to what quadrant I'm in. Since I'm in quadrant 2, ASTC, only sign is positive, which means this is a negative 5 over 13. And I know that because since I was giving this x value, because that's going to be our x values, but I'm going from the origin to the left, which those are your negative numbers. So that would be a negative 5. So it's cosine equals negative 5 over 13. Number 11, using the identity sine squared theta plus cosine squared theta equals 1, find the value of tangent of theta to the nearest hundredth if cosine of theta equals negative 0.7 and theta is in quadrant 2. So very important piece of information, cosine. It's telling you the value for cosine. So I can plug that into my equation. So sine squared theta plus cosine is negative 0.7 squared equals 1, because this is cosine theta right there. It's not telling me the value of cosine squared, it's just telling me cosine, so I do need to go ahead and square that. But just like before, to save time, I'm going to subtract it. So I get sine squared theta equals 1 minus 0.7 squared. I forgot the negative, but a negative squared is going to be positive anyways. So that's 0.51. So sine squared theta equals 0.51. And then to get just sine, because in order to find tangent, I need to find sine, not sine squared. So I'm going to square root both sides. So my square root and my square cancel. So sine of theta equals, I'm just going to leave this as the square root of 0.51. It's not going to be a very nice number at all. So now last step, tangent. I know that tangent of theta equals sine of theta over cosine of theta. And it already told me cosine was negative 0.7. And I just found sine is the square root of 0.51. So it says to round this to the nearest hundredth. So square root of 0.51 divided by negative 0.7. Oops. Gotta do that again. Square root of 0.51 divided by negative 0.7. And we get negative 1.02 because that's our nearest hundredth. So negative 1.02. So tangent of theta equals negative 1.02. And then just double check that the sign is correct. It said that it's in quadrant 2. So ASTC. Sine is positive in quadrant 2, which means my tangent should be negative, which it is. So we're all set with our answer. Negative 1.02. Number 12. On the axes below, graph one cycle of a cosine function with an amplitude of 3, period of pi over 2, midline y equals negative 1, and passes through the point 0.02. So first I'm going to sketch my midline. It's y equals negative 1. So that's negative 1 right there. It goes through the point 0.02, which is that point that I just drew. It has a period of pi over 2, which means if I draw in my 4 sections, that last tick mark is where pi over 2 should land. You don't need to worry about labeling the in-betweens. I know in class we did the x scale. You would do your period divided by 4 to find how much each tick mark goes up by, but you don't have to worry about that as long as you label the last tick mark with whatever the period says it is. That has to be labeled. Now my amplitude is 3, so if I have a c plus a, my c value is negative 1 plus 3 gives me a maximum of 2, which just happens to be the point that we already labeled. And then c minus a, so that's negative 1 minus 3. That's going to be a minimum of negative 4. So I already have negative 1 marked. I'm going to mark my minimum, negative 4. And then I can go ahead and start my graph. It is cosine. So cosine starts at the maximum, then goes to your midline, then goes to the minimum, back to the midline, and then finishes up at the maximum. And there is one cycle of our graph, one cycle of cosine. On the axes below, sketch at least one cycle of a sine curve with an amplitude of 2, a midline at y equals -3/2, and a period of 2 pi. So the period of 2 pi, that tells you where your last tick mark should end. That tells you how long it takes for one cycle. So I have 1, 2, 3, 4. That's 2 pi. My midline is -3/2. Well, that's -1.5. So if this is -1 and this is -2, my midline is going to be right in the middle. Y equals -1.5. The amplitude is 2, so I need to find my max and my min. So my max is C plus A, and my min is C minus A. So that's -1.5 plus 2, which is 0.5, and -1.5 minus 2, which is -3.5. So the highest I need to go up is +0.5, so here would be 1. So 0.5 would be below that. And then I need to go down to -3.5. And then I need to just make my point. So this is sine, so I start at my midline. Then I go up to my maximum, which is 0.5. Then back to my midline, down to my minimum, which is -3.5, and then finish at your midline. And that's it, one cycle of the sine curve. What's very important is that you're remembering to label all of this. There's a follow-up question right below it. It says, explain any differences between a sketch of y equals 2 sine of x minus pi over 3 minus 3 over 2. And the sketch from part A. So my sketch from part A, if I take my information, I had an amplitude of 2 and a midline of -3 over 2. That would give me the equation y equals 2 sine of bx. B is how long it takes, or how many cycles are in 2 pi, which we already said is one cycle because our period's 2 pi, so that's just 1x. And then our midline. The only difference between that and the equation we have below is I now have this minus pi over 3. And if you remember, again, we talked about this in part 1 of this video, your inside lies and it dictates if it's moving left or right. Since it's a minus, it's lying, it's going to the right. So this is just shifted pi over 3 units to the right. Everything else is the exact same. It already has the -3 over 2, because that was our midline to begin with, and it already has the amplitude of 2. So everything else stays the exact same. The only change is that this shifts to the right, again, because your inside lies. I will finish the next 1, 2, 3, 4, 5, 6, 7 questions in part 3 of this